Page 7, derivatives of exponential functions. So from your investigation or from page 374, write down the function which is its own derivative. So that, of course, would be e to the x. Using the chain rule, write down the derivative of e f of x. So that would be e f of x, because it's the derivative of its the derivative is itself. But you have to do the chain rule because this here is not x, it's f of x. So you need to multiply at the very end the derivative of this inside function f dashed x. Okay, so that would be using the chain rule with the exponential function. Find the gradient function for f of x equal to let's see, so what is the derivative of e to the 4x? So it's just e to the 4x, but we do need to take the derivative of this inside function, which would be 4. What about this one? Here we leave the 2 out front because a coefficient or a constant multiplied times function, it just stays there. And then the derivative of the exponential function is just itself, right? But you do need to take the derivative of the inside function, so it would be negative 1/2. Right? What about this one? This would be itself, e to the negative x squared, but then you need to take the derivative of negative x squared, which would be negative 2x to the first. Right? What about this one? The derivative would just be the function itself, but then you do need to take it times the, you do need to use a chain rule. So it would be just 2, right? Because the derivative of 2x plus 1 is 2. When they say x and that, it's the same thing as e to the negative 2x. The derivative of e to the negative 2x would be e to the negative 2x. It would be the function itself multiplied times the derivative of the inside function, negative 2, because the derivative of negative 2x is negative 2. Well, here we have two things added together, so we're going to have to use the addition rule. So the derivative of the first part would just be itself, except you have to multiply it times the derivative of the inside function. Derivative of x divided by 2 is 1/2. And the second part would be e to the negative x, so the derivative of e to the negative x would be negative 1. Next one. So here we have 10 times 1 plus e to the 2x quantity in parentheses. So we're going to, I think the easiest way to do this is multiply it out. So we have 10 plus 10 times e to the 2x. So if we take the derivative of this, the derivative of 10 is 0. And the derivative of 10 e to the 2x is 10 e to the 2x times the derivative of 2x, which is 2. And this last one, the derivative of e1 minus 2x squared would be e to the 1 minus 2x squared times the derivative of 1 minus 2x squared, which would be negative 4x. Alright, moving on to number 2. Find the derivative of x e to the x. Okay, now we have x, and we know how to take the derivative of e to the x as separate functions, but we do not know how to take as a function. Now, we can use a product rule, right? So the product rule says that we're going to say that u equals x, so u dashed is equal to 1, and v equals e to the x, so v dashed is equal to e to the x also. And then we're going to say, okay, so we have v dashed equals e to the x. And so now we're going to use the product rule. Remember, the product rule says that the derivative equals u v dashed plus u dashed v. So here I'm going to take u u, which is x, so the derivative is x. V dashed would be e to the x, plus u dashed, which is 1, I don't need to write anything, times v, which is e to the x. So there we go. Now e, we're going to divide this into two parts. One part is x squared, we know how to take the derivative of that, and the other is e to the 3x, we know how to take the derivative of that. We don't really know how to take the derivative of this whole thing together unless we use the product rule. So u is equal to x squared. U dashed is equal to 2x. V is equal to e to the 3x. V dashed is equal to e to the 3x times 3. So the product rule says that we're going to, when we take the derivative, it's going to be u x squared times v dashed, which is e to the 3x times 3. Put the 3 out the front because that looks nicer. Plus u dashed, which is 2x times v itself, which is e to the 3x. Okay. What about c? C, we have one thing divided by another thing, but so far we only know the product rule. So let's treat this as u would be e to the x, and v would be 1 over x, or another way to write that, it's easier to see the power rule if we write x to the negative 1. So in this case, u dashed is equal to e to the x, and we don't need to take the chain rule because it's just x. And v dashed would be negative 1 times x to the negative 2. Now, the power rule says that the derivative would be e to the x times v dashed, which is negative 1x to the negative 2, plus u dashed, which is e to the x, v, which is x to the negative 1. Okay? Last one. So we have square root of x and e to the negative x. Let's write square root of x in an easier form so that we see that it's easily done with the power rule. X to the 1/2, right? U dashed would be equal to 1/2 x to the negative 1/2. And v would equal e to the negative x, and v dashed would be e to the negative x times negative 1. We'll just put a negative right there. So the power rule says that the derivative would be x to the 1/2 v dashed, which is negative e to the negative x, plus u dashed, which is 1/2 x to the negative 1/2, times v, which is e to the negative x. Okay? Now 3. Find the gradient of the tangent, and remember gradient of the tangent is just another way of saying the derivative, 2, except in this case they're actually telling us to evaluate the derivative as certain x. So after we take the derivative, we're going to plug x equals 0 into the derivative we get. Remember to do that last. Okay, so first of all, what's the derivative of this? Okay, so this is just, we're going to take we're going to use the power rule, and then we're going to take the derivative of what's inside. So first we'll do 4 times this thing that's inside to the third. That's using the power rule, right? And we just write exactly what's inside there. And then we take the derivative of what's inside. The derivative of what's inside. So the derivative of e to the x is e to the x. The derivative of plus 2 is 0. Okay? Now we're going to evaluate it at x equals 0. Okay? If we put x equals 0 in here, remember anything to the 0 is 1. So if we have 4 times e to the 0 would be 1 plus 2 to the third, and then the last one is e to the x would be e to the 0, which is also 1. So we have 4 times 3 to the third, which 3 to the third would be 27, right? 4 times 27 times 1, and that would be about 108 or something like that, right? 108. Okay? Alright, next one. So first we're going to take the derivative of that, and then once we take the derivative of it, then we're going to plug in natural log 3. So first, let's rewrite this. It's going to be it's going to be an equivalent expression, same expression, except for we're going to write it with a power of 1/2. So it looks more easily differentiated using the power rule. So to do the power rule, we put the power out front. Then we write down exactly what was inside again. And then we put negative 1/2 because we reduced the power by 1. And then we take the derivative of what's inside, e to the 2x, and then we have to use the chain rule, so it would be 2e to the x. And then the plus 10, take the derivative of that, so 0. Okay, now we evaluate this at x equals natural log of 3. When we do that, since they use such a nice number, natural log of 3, some of the things are going to, let's see, we're going to e times 2 to the natural log of 3 plus 10 to the negative 1/2 2e to the 2 natural log of 3. Okay. Let's see. If we have, remember, let's do a calculation here to the side. E to the 2 natural log of 3. What does that mean? It's the same thing as if we did e to the natural log of 3 times 2. And that's the same thing as e to the natural log of 3 squared. And e to the natural log of 3, e to the something and natural log of something are inverses of each other. So if you do e to the natural log of something, you get the something. So this reduces to 3. It's 3 squared. 9. 3 squared equals 9. Okay? So every time we see e to the 2 natural log of 3, that is the same thing as 9. So I'm going to color those in green. So let's see. Like, for example, this here, that is equal to 9. And there's another one right here, e to the natural log of 3, that is equal to 9. So whenever I see that, I can replace it with a 9. So I have 1/2, 9 plus 10, so it'll be 19 to the negative 1/2. And then I have 2 times 9, because that green part is 9, and so this would be 18. And so that is, so we could, divide 18 by 2 and we get 9 here. So we have 9 in the numerator, and the denominator we have the square root of 19. Right? Okay. Alright, check your answers using technology. Okay, let's see how we would do that. We would put in the function, like let's start with 3a. We're going to put the function e to the x plus 2 in the calculator. So we'll put y equals, and there's a function in there, so I erase it. And then I'm going to put parentheses, e to the x plus 2 parentheses to the 4th. Okay, and I'm going to graph that, and I'm going to see what the derivative is at x equals 0. And I'm supposed to get something like 108. I don't see anything. Okay. Let's do a zoom. Standard. Graph. Okay, let's do a zoom fit. Okay. And let's find what is the derivative at x equals 0. The way we do that is second calc dy dx, and then we type 0. And it says it's 108. Hey, that's exactly what we got. So checking with technology, 108 happens to be correct. Thank goodness. Okay, now let's try a different one. Let's try this one here. So now we're going to do e to the 2x plus 10 root. Okay, so that'll be, let's see, e to the 2x plus 10 root square root of 2, or the square root. So I put root 0.5, for example. That's another way of doing root. And then I'm going to graph this, and then I'm going to look at x equals natural log of 3. I'm not sure if I can do that just by, let's see. No. Let's do a zoom fit. See what we get. Okay, and natural log of 3, I think, is going to be like a number that's about 1 or something like that. But so let's see if we can do that. We're going to type in natural log of 3. We'll see if we can do that. So we'll go second, or we'll do natural log. Oh, it didn't work. So let's just see what natural log 3 is first. Natural log of 3 is 1.099. So I'm going to graph it, and then I'm going to do second calc, dy dx, and I'm going to do 1.099 because that's natural log of 3. And I get 2.07. 2.07, about. Now is 9 divided by square root of 19 2.07? Let's check. 9 divided by square root 19. Oh, it is 2.07. Okay, so checking with technology, those two answers look correct. Okay, so this answer was correct, and this answer was correct. All right, number 4. Given that this function e to the kx plus x and f dash 0 equals -8, find k. Now this is just a giant algebra problem. So first we're going to do is, it says, hey, if you take the derivative of this and plug in 0 and set it to -8, then we want to find out what the value of k is. So let's take the derivative of this first. Remember, k is not a variable, k is a constant, so treat it just like a number. When you take the derivative of e to the kx, you get k e to the kx, right? E to the kx is the derivative, and then you take the chain rule, and then you end up with k multiplied out front. And then the derivative of plus x is plus 1. Okay, so that is the derivative, that's f dashed. Okay, now let's plug in x equals 0. When you plug in x equals 0, you're going to get k times e to the 0. You're going to get k times e to the 0, which is 1, so you're going to get k plus 1. And then you set that equal to -8, and then you find out that k is equal to -9. You get it? Okay? Because when x is 0 here, e to the 0 is 1, so it kind of disappears, and then you just end up with k plus 1. Alright, number 5. That was actually an easy one, right? By substituting e to the log, natural log 2 for 2 in y equals 2 to the x, and that's fine to do, right? Because e to the natural log 2 is 2. E undoes natural log undoes e. So if you, let's do that. So we're going to replace 2 here, y equals 2 to the x. Instead of y equals 2 to the x, we're going to put y equals e to the natural log 2 to the x. Okay, and then we're going to find dy dx of this. So if we do that, then we know that we're just going to rewrite. It's going to be the same thing over again, because if you take the derivative of an exponential, it's just the same thing. It's the exponential function, but then you take the chain rule of what's here, and then so you end up with natural log of 2 multiplied afterwards. And so now we have e to the natural log 2. We know it's 2. So actually what you end up with is natural log 2 times 2 to the x, right? Okay, so that is what we end up with in A. Now B, show that if y equals b to the x, where b is greater than 0 and b is not equal to 1, then dy dx equals b to the x times natural log of b. And notice that's what we got here. If you replace all the 2's with b, that's what we got. So can we do the same thing here? So we're going to replace b here. Instead of b, we're going to replace it with e to the natural log of b. So we're going to say, okay, y is equal to e to the natural log of b x. It's the same thing, right? So now we're going to take the derivative. Remember, natural log of b is a number, so all you need to do is rewrite the whole function here and then do the chain rule, so you end up with multiply times natural log of b. And so that's the same thing as, and notice that e to the natural log b is just the same thing as b. So now you have b to the x and times natural log of b. And hey, that is exactly what we were supposed to show. Okay? And so that's it for page 7.